Hello everyone and welcome back to our VectorX Academy. This is Satyatej and today we will be briefly discussing on multinomial equations and then we will go into problems. So let's get right into it. Now what is multinomial? Multinomial is a polynomial with degree n. That's where n should be greater than 2. If we take n is 2 then it is a quadratic polynomial. If we take n is equals to 3 then it will be a cubic polynomial. If we take n greater than 3, it will be multinomial. Now let us take for n equals to 3. Let us take the general equation ax cube plus bx square plus cx plus d equals to 0. Now, if this equation has roots alpha comma beta comma gamma, then ax cube plus bx square plus cx plus d equals to can be written as a times alpha x minus alpha into x minus beta into x minus gamma. That implies ax cube plus bx square plus cx plus d can be written as a times x cube minus alpha plus beta plus gamma times x square plus alpha beta plus beta gamma plus gamma delta times x minus alpha beta gamma, that equals to x cube plus b by ax square plus c by ax plus d by a equals to x cube minus of alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma delta times x minus alpha beta gamma. That implies we get minus b by a as alpha plus beta plus gamma by comparing these two equations. C by a is equals to alpha beta plus beta gamma plus gamma delta, and finally minus d by a is equals to alpha beta gamma. That means we got that sum of roots taken one at a time is equals to minus coefficient of x square by coefficient of x cube, and summation of roots taking 2 at a time is equals to minus plus coefficient of x by coefficient of x cube, and summation taking 3 at a time alpha beta gamma is equals to minus coefficient of minus constant by coefficient of x cube. Now similarly for degree n greater than 3, if we take the general equation as a n x power n plus a n minus 1 x power n minus 1 plus and so on plus a1x plus a naught equals to 0, and assume alpha 1 comma alpha 2 comma and so on alpha n be roots of the above multinomial, then we will get summation of alpha i's I equals to 1 to n as minus a n minus 1 by a n, and summation alpha I into alpha j taking 2 at a time I greater than j from 1 to n will be a n minus 2 by a n. and summation alpha I, alpha j, alpha k, taking 3 at a time. 1 greater than equals to I, greater than j, greater than k, equals to n, will be minus a n minus 3 by a n. And if we go on like that, we get product of all roots a1 into a2 into and so on an will be minus 1 power n into a naught by an. Now let us do some problems regarding this. Let us take this question. The product of two of the four roots of a quadratic equation x power 4 minus 18x cube plus kx square plus 200x minus 1984 equals to 0 is minus 32. Determine the value of k. Now, if we take the roots of equation x power 4 minus 18x cube plus kx square plus 200x minus 1984 equals to 0 as alpha comma beta comma gamma comma delta, then we get alpha into beta as minus 32 as they are given in the equation, they are given in the question. Now from this, substitute alpha beta in this one, we know that product of roots alpha into beta into gamma into delta will be minus 1 whole power 4 into minus 1984 by 1. That means minus 32 gamma delta will be 1984 minus. That means 62. Gamma delta will be 62. Now, we also know that alpha beta gamma plus alpha beta delta plus beta gamma delta plus alpha gamma delta will be minus 1 whole power 3 into minus 200 by 1 plus 200. That means take alpha beta common from these two and gamma delta common from these two. We will get alpha beta times gamma plus delta plus gamma delta times alpha plus beta equals to minus 200. We know alpha beta and gamma delta. Substitute those values. We will get minus 32 times gamma plus delta plus 62 times alpha plus beta equals to minus 200. That means minus 16 gamma plus delta plus 31 alpha plus beta equals to minus 100. Now take this as equation number 1. We also know that alpha plus beta plus gamma plus delta will be minus of minus 18 by 1. That equals to 18. Alpha plus beta plus gamma plus delta. Take alpha beta as L and gamma delta as M. Now we get and take this as equation number 2. Equation 1 will be minus 16 M plus 31 L equals to minus 100. And second equation will be L plus M is equals to 18. Now multiply equation number 2 by 16 and add these two equations. We get minus 16M and 16M will be cancelled out and we get L times 47 is equals to 18 into 16 minus 100. That is L times 47 equals to 18 into 16. Now I will show you a trick to multiply two digit 18, 16, 6 8 of 48, 8 plus 6, 14, 111, 288. 288 minus 100. That implies 47L is equals to 188. 47, 188, 28, 4 times. L equals to 4. That means we got alpha plus beta as 4 and alpha beta as 32, minus 32. From these two we get alpha as minus 8, alpha plus 8, beta as minus 4. You can also solve this by squaring alpha beta and substituting like a quadratic equation. No, we got L as 4. That means M will be 14 from equation number 2. And we know that gamma delta equals to 62 and gamma plus delta equals to 14. That means gamma square plus delta square plus 2 gamma delta equals to 196. Gamma delta will be 62. Sorry, 31. My bad. Oh, sorry. 2 gamma square plus delta square plus 2 times minus 2 gamma delta equals to 196 minus 4 times 62. That means gamma minus delta whole square equals to 196 minus 4 8 24. 196 minus 248. 248, 196, 2, 14, 5, minus 52. Therefore, gamma comma delta will be imaginary. Now what we want? We want k. And what is k? Coefficient of x squared. That can be written as alpha beta plus beta gamma plus gamma delta plus beta alpha plus alpha gamma plus beta delta. Now we know alpha beta and gamma delta. Sorry, gamma delta. That implies k take alpha common from these two and beta common from these two. We get alpha beta plus gamma delta plus alpha times gamma plus delta plus beta times gamma plus delta. That means k equals to what is alpha beta? Minus 32. What is gamma delta? 62 plus what is gamma plus delta? 14. 14 times 4 alpha beta. That means k equals to minus 32 plus 62 plus 56. That equals to 56 plus 30, 86. We got value of k as 86. Now, we will go into next question. If P of x denote polynomial of degree n such that P of k equals to k by k plus 1 for k equals to 0, 1, 2 and so on up to n, determine P of n plus 1. Now, for this kind of questions, there is a method. We will do in that method. Given that P of k equals to k by k plus 1, k by k plus 1. For all belongs to no k equals to 0, 1, 2 and so on n. That means P of k into k plus 1 equals to k for all k equals to 0, 1, 2 and so on n. That implies P of k into k plus 1 minus k equals to 0 for all k equals to 0, 1, 2 and so on n. We know that this is a degree of polynomial n and this is 1. So whole, if we take this whole as another function f of x, then the roots of the f of x will be 0, 1, 2, and so on n. Therefore, f of x can be written as a times 0 into x minus 0 into x minus 1 into and so on x minus n. That means p of x into x plus 1 minus x is equals to ax of x minus 1 into and so on x minus n. That implies p of x will be a times x into x minus 1 into and so on x minus n by plus x by x plus 1. Now, what they are asking, determine the value of n plus 1, p of n plus 1. Also, they have given that p of k equals to k by k plus 1 for all k equals to 1. Take k equals to 1, then we should get 1 by 2. So, substitute these two, we get 1 by 2. So, clearly it satisfies for all n. Now, substitute x equals to n plus 1. We get p of n plus 1 as a times n plus 1 into n into and so on up to 1 plus n plus 1 by n plus 2. That means n plus 1 factorial into a plus n plus 1 by n plus 2. Now we got p of n plus 1 as a times n plus 1 whole factorial plus n plus 1 by n plus 2. Now what is a? To find out a, we know that f of x equals to 0 has roots and f of x is a times x minus 1 into x minus 1 into x minus 2 into hence on x minus n. Take f of x can be written as p of x into x plus 1 minus x by equals to a times x into x minus 1 and so on x minus n. Now take x equals to minus 1. That means x equals to minus 1, p of minus 1 into 0 plus 1 equals to a times minus 1 into minus 2 into and so on, minus 1 minus n. That implies 1 equals to a times minus 1 whole power n into n plus 1 whole factorial. That means we got a as 1 by minus 1 into n plus 1 into n plus 1 whole factorial. Now substitute the value of a in p of n plus 1. We get minus 1 whole power n plus 1 into n plus 1 factorial by n plus 1 factorial plus n plus 1 by n plus 2. That equals to minus 1 whole power n plus 1 plus n plus 1 by n plus 2. Depending on n, whether it is odd or even, we get the final value. Therefore, p of n plus 1 will be minus 1 whole power n plus 1 plus n plus 1 by n plus 2. Now let's go into the second question. Third question. If roots of x power 4 plus ax cube plus bx square plus ax plus 1 equals to 0 has real roots, then find the minimum value of a square plus b square. So they are asking the minimum value of a square plus b square. But they have given it is a fourth degree polynomial. X power 4 plus ax cube plus bx square plus ax plus 1 equals to 0 has all real roots. Now we should make this into a quadratic equation. As this is symmetric about x square, divide whole equation by x square. We get x square plus ax plus b plus a by x plus 1 by x square equals to 0. Now, this can be written as x square plus 1 by x square plus 2 plus a times x plus 1 by x plus b minus 2 equals to 0. Now, this can be written as x plus 1 by x whole square plus a times x plus 1 by x equals to plus b minus 2 equals to 0. Now, this is a quadratic equation and here x plus 1 by x. The minimum value of x plus 1 by x is x plus 1 by x minimum value is 2 for x equals to 1. How we can find it as? No, this can be written as x square plus 1 by x and minimum value of x square plus 1 by x. Differentiate it. We get 1 plus minus 1 by x square should be 0. That means x square minus 1 should be 0. That implies x should be plus or minus 1. It implies x plus 1 by x belongs to minus infinity to minus 1, minus 2, union 2 to infinity. Now, let us find the roots of this equation. We get x plus 1 by x whole square plus a times x plus 1 by x plus b minus 2 equals to 0. Take x plus 1 by x as k square plus ak plus b minus 2 equals to 0. That implies k will be minus a plus or minus root over b square minus 4 times ac by 2a. And we need minus a plus or minus root over a square minus 4b plus 8 by 2 should be greater than 2. That means minus a plus or minus root over a square minus 4b plus 8 should be greater than 4. That implies plus or minus root over a square minus 4b plus 8 should be greater than 4 plus a square on both sides. We get square on both sides. We get a square minus 4b plus 8 should be greater than a square plus 16 plus 8a. That implies minus 4b plus 8 should be greater than 16 plus 8a. Minus b should be greater than 8, 8 times and 2 times, 2 plus a. That implies again square on both sides. We get b square should be greater than 4 plus a square plus 4a square plus 2 into 2, 4 into 2, 8, 8a. That implies add a square on both sides. B square plus a square should be greater than 4 times 4 plus 5a square plus 8a. Now, if we find the minimum value of this, we can get the value of a square plus b square. That equals to that implies minimum value of 4 plus 5a square plus 8a. The minimum value of this equation will be at minus b by 2a x. That implies x will be minus 8 by 2 into 5 minus 4 by 5. Therefore, the minimum value of the equation 4 plus 5a square plus 8a will be 4 plus 5 into 16 by 5, 16 by 25, in plus 8 into minus 4 by 5. That equals to 4 plus 16 by 25, 16 by 5, 1 5 will be cancelled out. So 16 by 5 plus 8 into 4 minus 30, minus 32 by 5. 4 plus minus 16 by 5. That equals to 4 by 5. Therefore, the minimum value of a square plus b square is 4 by 5. Now to the next question. If a and b are the two roots of equation x power 4 plus x cube minus 1 equals to 0, prove that ab is a root of x power 6 plus x power 4 plus x cube minus x square minus 1 equals to 0. So they are saying that x power 4 plus x cube minus 1 equals to 0 has two of the roots as a comma b. Now let us take the another two roots c and d. Then we know that a plus b plus c plus d will be minus 1 and A into B into C into D will be 1 minus 1. That means AB will be minus 1 by CD or CD equals to minus 1 by AB. Take this as equation number 1. Now, substitute values of A and B in the given equation x power 4 minus x cube plus 1 equals to 0. That means we get a power 4 plus a cube minus 1 equals to 0 and b power 4 plus b cube minus 1 equals to 0. That means a power 4 plus a cube equals to 1 and b power 4 plus b cube equals to 1. Now we want a into b. So multiplies these two equations. We get a power 4 plus a cube into b power 4 plus b cube as 1. That means simplify this. We get a power 4 b power 4 plus a cube b cube into a plus b plus 1 equals to 1. That implies we get a plus b as 1 by a power 4 a cube b cube will be 1 minus a power 4 b power 4 a plus b plus 1. That implies a plus b will be minus 1 minus a power 4 b power 4 by a cube b cube minus 1. Now similarly, take for C and D also. So we will get C plus D as 1 minus CD whole power 4 by CD whole cube minus 1. And now we know that CD as equals to minus 1 by AB. Substitute this. We will get C plus D equals to 1 minus 1 by AB whole power 4 by minus 1 by minus 1 by AB whole cube minus 1. That equals to AB power 4 minus 1 by minus AB minus 1. That equals to 1 minus AB whole power 4 by AB minus 1. Now take this as equation 3 and this as equation 2. From 2 and 3, we know that A plus B plus C plus D is minus 1. That means substitute A plus B value and C plus D value. We get 1 minus AB whole power 4 by A cube B cube minus 1 plus 1 minus AB whole power 4 by AB minus 1 equals to minus 1. Take out 1 minus 1 as cancel and now we will get 1 minus AB whole power 4 minus A cube B cube plus A square B square minus AB whole power 6 equals to 0. Now AB equals to x, substitute, we will get 1 minus x power 4 minus x cube plus x square minus x power 6 equals to 0. That equals to x power 6 plus x power 4 plus x cube minus x square minus 1 equals to 0. Hence proved. We got the final equation. Therefore, AB is the root of equation x power 6 plus x power 4 plus x cube minus x square minus 1 equals to 0. This completes our today's class. And now, thank you for attending.